Hello students. This video is for textbook lesson 2, or lesson 6 actually, of chapter 2, so it's lesson 2.6. And the title of this lesson is Solving Equations Using Multiplication or Division, where our objective is to solve equations using multiplication or division. Our vocabulary, and actually it's review vocabulary, is solving an equation, inverse operations, and equivalent equations. These three vocabulary words we had in our previous lesson where we were solving equations using addition and subtraction, and now we're moving on and we're going to be solving some equations using multiplication or division. So astronomy. In 1995, the Solar Heliospheric Observatory, known as SOHO, was launched into space. SOHO studies the sun, including high-speed gas called solar wind that is ejected from the sun and travels throughout the solar system. In example 3, you'll see how to use the multiplication equation to find how long it takes solar wind to reach Earth. You can use division to solve such an equation because multiplication and division are inverse operations. So in our last lesson, we talked about solving equations using addition and subtraction, and we learned that addition and subtraction are inverse operations to one another, and now we learn likewise that multiplication and division are also inverse operations. Remember, I'll often use the opposite operation, and pretty much whenever I say opposite, I'm referring to the inverse operation. So looking at our division property of equality, meaning what we do to one side we can do to the other, and whenever I say one side and the other, I'm talking about one side of the equal sign and the other side of the equal sign, and this is why we call these properties of equality, because it refers to what we're doing to each side of the equal sign there. And also just a little bit of a review here in our last lesson. And I'm distracted because I got black ink this time. I'm usually, you know me, I like to write in red. So in our last one, we talked about how we, and I didn't quite get this line on there. There we go. We talked about how an equation is like a scale. And if we have items over here on this side, right, then we would have to, for it to be balanced, we would have to have the same items over here on this side. And if we do anything to one side, we're going to have to do the same thing to the other side in order to keep it balanced. So a little bit of review there on the idea of the properties of equality. What you do to one side, you have to do to the other. So in words, we say that dividing each side of an equation by the same non-zero number produces an equivalent equation. And this word non-zero is important here. Looking over at our watch out notification, it says, remember that you cannot divide a number or any expression by zero. Zero can be in the numerator. So we could have a 0 in the numerator and a 4 here, and 0 divided by anything is going to be 0. So this is allowed. However, we can't go the other way. We can't take 4 and divide it by 0. And this here is what we call undefined. And whenever you get into geometry and you start graphing, well, actually in algebra we'll graph equations too. But whenever you start graphing equations, you'll find out the relationships between what the graph of an undefined equation is. So with that said, let's go ahead and look at the number section. If 3x equals 12, then 3x divided by 3 is equal to 12 divided by 3. So notice that we are doing the same thing to both sides of the equation. That is that we're dividing it by 3. And what happens here is the 3's are going to cancel each other, and we're going to end up with x equals 4 because, well, 12 divided by 3 is 4. Now you might wonder, so what's going on here? Why does dividing by 3 just make this 3 disappear and all we end up with is x? So we're going to take a look at that. Let's go with 3x. If we take 3x and we divide it by 3, what would we get? The question is, what does this equal? Well, let's write this another way. I could write this as 3x over let's see, 1 times 3, right? And actually, I think I'm going to take a step back right there, and I'm actually going to write this as 3 times 1. I'll put the 1 there first. Now, one thing we know about fractions is that with fractions such as 2/3 and let's say 4/5, right? If we multiplied these, we know the rule is we just multiply straight across, numerator times numerator, denominator times denominator, and we end up with 8/15, right? And so with that idea of understanding of how fractions are multiplied, let's go ahead and look at how that affects this situation here. So if I put that together, and can I undo that? Yep. So if I went the other way, I could actually pull the 8 apart into 2 times 4, right? And I could represent the 15 as 3 times 5. And then I could pull it back apart again, back to 2/3 and 4/5. So doing the same concept here, I'm going to go ahead and pull the 3x and make this, nope, not a 2, Mr. T. I'm going to make this 3 times x and make this 3 times 1. Now I can then go ahead and write this as 3/3 times x over 1. And we know that any number over itself is equal to 1. And any number divided by 1 is equal to itself. So 3/3 becomes 1. X over 1 becomes x. And anything, now I got to have 1 times x, and anything times x, or anything times 1 equals itself. So 1 times x is going to equal x. So in the end, let's take what we have here, 3x/3 equals, and what do we get at the end? We see that it indeed just equals x. And so basically what happens is just what's happening right here, where 3/3 ends up being equal to 1, and it just kind of cancels itself out and goes away. So whenever you see me say that the 3 cancels a 3, and you'll see me cross them out like this and say, oh, that just leaves me with x, right? That's what's happening there. So if that seems a little confusing, or you really want to understand, I mean, you could just learn the shortcut and like, oh, it's like a magic trick that you divide by the same number and it just like disappears. But if you want to see that again, you could always rewind the video and look through that process there and understand how that process works. So working this horizontally up and down instead of across, if I had 3x equals 12, not 11, but 12. And then I say, okay, the 3 is tied to the x through multiplication, right? And the opposite operation, or the inverse operation of multiplication, is division. So I'm going to divide. What am I going to divide by? The number I want to get rid of, which is 3. And what I do to one side, I have to do to the other. So now the 3's will cancel each other, leaving me with x over on the left, and 12 divided by 3 is 4. Now this works for every numbers, no matter what they are, as long as a is not equal to 0. So a times x equals b, and as long as a is not equal to 0, because a is going to be a denominator, then a times x divided by a is equal to b divided by a. And then the a's cancel each other, leaving you with just the x, and then you end up with ba on the right. Now, I normally won't say a times x. I'll say ax equals b. Then ax over. And so instead of saying a times x divided by a, I'll say over. Whenever I say over, hopefully you'll understand that I'm talking about a fraction. So I read this as ax over a equals b over a. But that's not to say that I won't say divide. Sometimes I might say ax divided by a equals b divided by a. Sometimes I'll say over, sometimes I'll say divided. So let's go ahead and look at our next example here that they gave us. Here it says to solve negative 6x equals 48. So rewrite the original problem, negative 6x equals 48. And so the negative 6 is tied to the x through multiplication. The opposite operation is division, so I put my fraction bar. The number I wish to get rid of is negative 6, so that's what I'm going to divide by, is negative 6. What I do to one side, I have to do to the other. Negative 6 over negative 6 is equal to 1, so they cancel each other out, leaving me with just x. And 48 divided by negative 6, well, positive divided by a negative is a negative, and 48 divided by 6 is 8. So the solution is negative 8. And just like we learned in the previous lesson, where you can take your solution and plug it back in, let's go ahead and take this solution in negative 8, plug it back in, so negative 6x, so we put a parentheses wherever the x goes. And so we end up with negative 6 times negative 8, and negative 6 times negative 8, well, negative times negative is positive. 6 times 8 equals 48, and this 48 came down on the right, and does 48 equal 48? Indeed it does. So represented with a check mark, so the solution checks out, therefore the solution is correct. So what about multiplication? What if it's tied? What if the variable is tied to the number through division? So we're going to use the multiplication property. So to solve an equation that involves division, you can use the multiplication property of equality, because division is the inverse operation of multiplication. Use the inverse operation to undo something. So multiplication property of equality, multiplying each side of an equation by the same non-zero number produces an inequivalent equation. So in numbers we say that if x over 3 equals 12, then 3 times x over 3 is equal to 3 times 12. Or we could say that x equals 36. So let's look at what's going on there. I have x over 3 equals 12. And supposedly, so if I multiply each side by 3, this is going to work out, right? Well, let's see why that is that we end up with just x in this case. And the 12 times 3 is going to be 36. But why does 3 times x over 3 equal just x? So let's look at that. I'm going to go ahead and erase here so I can have some more space. Let's go ahead and do that. And so we're saying that x over 3, and if we multiply it by 3, then somehow we're going to equal just x. The whole fraction thing is going to go away. We're going to get rid of that denominator of 3, and we'll see how that works. So looking at this, let's write 3 as a fraction, 3 over 1. And we're multiplying that by x over 1. Now we'd end up with 3x over, yep, there we go, yep, over 1, making sure I'm doing this correct. And I paused and I realized what I did. That's not, there we go. That's x over 3, right? Not 1. So here's the 3. My 3 is just being represented as 3 over 1 as a fraction. And then I bring over my x over 3. Now I put those together, I end up with 3 times x. And this is 1 times 3, right? Multiplying fraction, multiplying straight across. I could rewrite this expression here as I could just flip those around in the denominator, so I could have 3x over 3 times 1, commutative property of multiplication. Now I could actually pull those apart. 3 over 3 times x over 1, and I might need a little more space. And then this 3 over 3 is going to become 1, because any number over itself is equal to 1. And then any number divided by 1 is equal to itself, so this right here is going to give us times x. And then anything times 1 is equal to itself, so I just get x. So that's why 3 times, not 1 over 3, but x over 3, 1 times x over 3 is equal to x, because the 3's cancel each other, and we see that happening right here in that step. So if you're wondering why is it that whenever you do that, that the numbers just kind of disappear and you simply end up with the x right here, that's because all of this is going on right here. So we can say in algebra, we can say that if x divided by a equals b, and a is not equal to 0 because we can't divide by 0, then a times x over a is equal to a times b. And this portion on the left simplifies down to just x, and then we have a times b on the right, so it all equals x equals ab. So let's look at this example here. For example 2, we have solved 9 equals W over 7. So rewrite our original equation. 9 equals W over 7. Well, the W is tied to the 7 through division, so we're going to use multiplication. We're going to multiply by the number we wish to get rid of, which is 7. And what we do to one side, we're going to do to the other. The 7s are going to cancel each other right here, right? Leaving us with just W, and 7 times 9 is 63. Therefore, the solution is 63. And you could go back and plug that 63 in. We got 63 for the solution of W, and then you could go ahead and check that answer. Well, 63 divided by 7, it is indeed 9, so that does check out. And while I'm here, a good thing I want to point out is that this works, this whole multiplying by whatever the denominator is. If you ever have a fraction and you want to get rid of the fraction, just multiply both sides by whatever the denominator is. And this would even work if you had like 3 over x plus 6. You could just multiply everything on both sides, 4/5, something like that. If you wanted to get rid of these fractions, you could multiply, actually do some cross product stuff there. But nonetheless, good strategy. Want to get rid of a fraction, multiply both sides by its denominator. All right, look at this first one here. We have 2x equals 18. So the 2 is tied to the x through multiplication. The opposite operation is division. We're going to divide by the very number we wish to get rid of, which is 2. And what we do to one side, we're going to do to the other. The 2's are going to cancel each other, leaving us with just x, and 18 divided by 2 is 9. On number 3 here, we have y divided by 2 equals 13. So we want to get rid of the 2, correct? And the 2 is related to the y through division, so the opposite operation is multiplication. What are we going to multiply? Well, that very number we wish to get rid of, which is that 2 in the denominator. So we're going to multiply both sides by 2, because what we do to one side, we do to the other. The 2's are going to cancel each other out, leaving us with just y on the left. And 13 times 2 is 26. So let's go ahead and look at that example about the SOHO. Was it a telescope? Yeah, it is a telescope. It's a special ultraviolet imaging telescope. So on January 4, 2013, the SOHO spacecraft described on page 97, that was back in the beginning, detected solar wind traveling at about 2 million kilometers per hour. It's pretty fast. The sun is about 150 million kilometers from Earth. About how long did it take the solar wind to reach the Earth? So our solution is to let t be time, in this case in hours, that it took the solar wind to reach Earth. Well, d equals rt is a formula that we use for distance traveled. D represents distance, R represents rate, and T represents time. So we're going to plug in what we do know. We know that the distance from the sun to the Earth is 150 million kilometers. Not because I've traveled it before, but simply because this textbook's telling me so. So I'm going to plug in the distance of 150 million. And the rate at which it travels is 2 million kilometers per hour. So I plug in my 2 million kilometers right here. Yep, 260 million. Yep. Time is what I don't know and what I'm trying to find out, so I'll leave t as t. Now, the 2 million is related to the t through multiplication. The opposite operation is division, so we're going to divide. We're going to divide by the very number we wish to get rid of, which is 2 million. So I divide the right side by 2 million. What I do to one side, I have to do to the other, so I divide the left side by 2 million as well. And then that's going to leave us 75. And we could do that by, you start canceling these zeros, start canceling those zeros out, and then what you end up with is 150 over 2. And 150 divided by 2 is 75. So you really wouldn't need a calculator to do this. You could use that strategy of letting those zeros cancel each other out. So it took the solar wind about 75 hours to reach Earth. And if you think about that, 75 hours is like 3 days and 3 hours. Interesting. So the solar wind that's leaving the sun actually takes 3 days and 3 hours to get here. So that means whenever the solar wind hits the Earth, it actually came from the sun that you were seeing 3 days ago. And whenever you look up at the sun now, the sun that's there now, the solar wind from what you're looking at is actually going to hit 3 days later. Interesting. The SOHO spacecraft took this photo of the sun using a special ultraviolet imaging telescope. Light from the sun travels at about 300 kilometers per second. How long does it take to reach the Earth? So let's go ahead and work that one out. So remember, and we're working in seconds. Because at first, whenever I looked at this, I'm like, well, that means 300,000 is less than 2 million. And so that means it takes the light longer to get to the Earth than the solar wind. That doesn't make sense. And then I'm like, oh, okay, it's each second, which up here we're talking about per hours. So we'll go ahead and work that out. So we're looking at distance equals rate times time. D equals RT. The distance in this case is still, the sun hasn't moved, it's still 150 million miles. So we need enough zeros there for that. Throw in our equal sign. The rate is 300,000. So we'll put 300,000 there. And we need to know time, which remember, we're talking about seconds. So the 300,000 is tied to the t through multiplication. The opposite operation is division. We're going to divide by the very number we wish to get rid of, which is, yes, 300,000. And what we do to one side, we're going to do to the other. So we need to divide this by 300,000. Now we can start canceling zeros out. So that one cancels that. Those three cancel them. That cancels that. So I end up with what's left is 1500 divided by 3. So 1500 divided by 3. Well, I know that if I just look at the 15 part here, I know that 15 divided by 3 is 5. And then now let's throw these two zeros back on. So it's going to be 500. And this time we're measuring time in what? I think I heard you say seconds. Yeah, I'm pretty sure I did. So 500 seconds. So if we think about 500 seconds, well, there's 60 seconds in a minute, right? So what if we took 500, divided it by, that's 500, divided that. Yep, I should be teaching a lesson now on unit rates, I suppose, and conversion factors. But if I have 500 seconds and there's 60 seconds in a minute, then I need to divide 500 by 60. Those would cancel it out. That would leave me 50 divided by 6. And 6 goes into 50, 8 times for 48. And then subtract that, that's 2. And then bring down the, bring down that 0 there, right? And 6 goes into 23 times, and it's going to go on. So it's roughly about 8.3. And this was seconds. We converted it to minutes. So the light that you are seeing from the Earth, or the light you're seeing from the Earth. Yeah, because the Earth produces light, Mr. T. The light that you're seeing from the sun actually left the surface of the sun just over 8 minutes before you saw it here on the Earth. So does that mean that sundown happens about 8 minutes before we think it does? I think should it be whenever the sun really does set, or whenever we see the reaction from it setting? Interesting thought. So for our guided practice, complete and copy and complete, multiplication and blank are inverse operations. Well, hopefully you're saying division. Yes, multiplication and division are indeed inverse operations, just like addition. Subtraction are inverse operations. Which property of equality would you use to solve x over 5 equals 12? Well, the 5 is tied to the x through division, and the inverse operation is multiplication. So I would use the multiplication property of equality to solve that. We'll work a couple of these out. Let's do number 4. Rewrite the problem. 54. Good practice to always rewrite whenever you're writing your problems out. That way, if you look back at your notes, you know which one you were working on. So the 9 is tied to the x through multiplication. The opposite operation is division. I'm going to divide by the very number I wish to get rid of, which is 9. And what I do to one side, I'm going to do to the other. The 9s are going to cancel each other, leave me with just the x on the right. And 54 divided by 9, I believe last time I checked, is 6. So we would say that x equals 6. Let's do number 5. Actually, let's do number 6. It involves a negative number, so a little bit of practice with negative numbers. So y over negative 10 equals 7. So the y is related to the negative 10 through division. The opposite operation is multiplication. So I'm going to multiply. What am I going to multiply by? The very number I wish to get rid of, negative 10. What I do to one side, I do to the other. The negative 10s are going to cancel each other, leaving me with just y on the left. And 7 times negative 10, well, positive times negative is negative, and 7 times 10 is 70, so y equals negative 70. And then if you want, you could go ahead and check this one out here. I always kind of like the error analysis, but they don't have one for us here. We're about 25 minutes into this video right now, so I'm going to go ahead and we're going to skip the inkjet printer sale. All right. So that's pretty much it for lesson 2.6, solving equations using multiplication or division. Thank you.